So the next talk, it's going to be from Sundas Khalid, who works basically, she's a lead data scientist at Google. Before that, she was at Amazon. She is also very active in a career coaching of younger data scientists and particularly women. So it's very nice that we have a talk from her in this PyData. One of the advantages basically of having a virtual PyData conference is that you have speakers from other continents, US in that case. So I will give basically the floor to Sundas. She can share her screen and see her presentation.
All right. First of all, sorry about that, everybody. It's the new world that we're living in, so we have to deal with all these technical glitches. So thank you so much for being patient and just helping us, just waiting and letting us go through this. So my talk today is going to be very lightweight. I know you have been attending talks all day, so I'm going to make sure I keep it very lightweight and as engaging as possible. And I would like all of you to use the chat box feature to kind of leave comments. If you have questions during the session, feel free to leave questions in the comment section or in the Q&A section. We will address those toward the end. And I just want all of you to enjoy the talk and just be engaging as much as you can. All right, so a little bit about myself. So my name is Sundas Khalid. You can go to the next slide. My name is Sundas Khalid. I am currently a senior analytical lead at Google. Previously, I was working at Amazon as a data scientist. My current work involves in the core search area, where I work on Google search advertisement space specifically. When I was at Amazon a year ago, I was working on the A/B testing platform, where I was supporting basically all the A/B testing methodologies that was being used by the retail, as well as Alexa, Prime, music, video, pretty much all the teams that are present at Amazon, and they were launching new features and they were testing, and before launching, they would test it. And depending on the A/B test results, we will either launch the feature or not launch the feature. Could you go to the next slide, please? Besides that, I run a side business as a career coach. I am a big advocate of diversity and inclusion initiatives. I currently serve on the board of 2 nonprofits, and I'm also facilitator for I Am Remarkable workshop. On my side, like my hobbies are public speaking, blogging, and community building. After the session, you can connect me on any of these sessions, on any of these social media channels. All right, so let's jump right into our topic for today. So I'm talking to all of you data people and all of you smart people. So you already know this, that data is the future. Just to put some perspective to it, there are 3.7 billion humans that are currently using the internet. And those humans have generated 40 trillion gigabyte of data just in 2020. And 90% of that data was created just in the last 2 years. And what's more staggering is that less than 1% of the data is actually analyzed today. So when we are talking about, when we're saying that the data is the future, there is a lot more data out there that is yet to be analyzed. So when we say data is the future, data is the future. Next slide, please. So we know that AI and machine learning has been revolutionary. Machine learning is a science of discovering patterns and finding relationships with data. It's powerful for creating personalized and dynamic experiences. And it has been revolutionary in many fields, including healthcare, education, military. One of my favorite examples is that machine learning and AI is currently being used for catching human traffic criminals, where image-based AI programs are capturing criminals using satellite images of areas in forced labors. So when we talk about that AI is changing our world, AI is truly changing our world for the good, and it has revolutionized many fields, and it continues to evolve. So, but that being said, there are biases that are inherently present in the human nature that end up being translated into the data and in the technology that we build. So before we jump into the next part of my talk, I want to do a small exercise with all of you. So feel free to use your chat box to kind of type. So could you please go to the next slide? So what I want all of you to do is imagine a shoe. Just think of a shoe and a type of a shoe, a color, a type, whatever comes to your mind, just think of it. And you can either type it in your chat box or you can just keep it to yourself, which is fine. So I'll give you a few seconds to think about it. All right, so let's go to the next slide. So how many of you thought of this shoe and this color? A sneaker, a running shoe. Next slide. Maybe a business casual shoe, a loafer. How many of you thought of this? Show of hands. Next one. How many of you thought of this? That's pretty. So next slide. So the idea is that all of us probably thought of a different shoe. And we may not even know it, but we all have bias toward one shoe or another. And they just come into our mind's eyes first. Now imagine that you are building an ML model that can recognize shoes. You may expose your perception of the shoe, whatever comes to your mind, in your bias in the model. And that's how biases happen in machine learning. Because with machine learning, you show a model many examples, and those examples are often labeled human-added descriptors. And if those labels have biases built in, then that bias gets engineered into the machine learning models. So it's really important to discover those biases early and figure out how to mitigate an effects as you are developing your machine learning models. Let's go to next. So we know that we have all heard this, that AI can be biased. And when AI and supercomputers and machine learning was introduced first, many people thought that this is going to revolutionize because it's going to remove all unfairness in the world. But somehow we overlook the fact that these AI models and algorithms are created by humans, and humans are inherently biased. These biases can be explicit or implicit, also known as unconscious bias. When algorithms are built, many decisions are taken by humans that decide what algorithms will do. And that's how the biases get introduced into the technology that we do end up building. So let's talk about some real world examples now where AI has actually impacted the real lives of people through its biases. There is a big bias present in a lot of the hiring systems that are out there. There was a study done by Harvard Business Review along with Northeastern University and USC, and they found that the ads on Facebook for certain jobs were targeting and they were biased. For example, 85% of the cashier jobs were targeted toward women, and 75% of the taxi driver jobs were targeted toward Black. And this is a case of bias without human intervention. And such recommendation systems are purpose-built to find and replicate pattern in user behavior, updating predictions dynamically as employers and job seekers interact. And there are systems out there that learn from, like, for example, if a system is learning from recruiters' behavior. So if a system that notices recruiters happen to interact more frequently with white men, it may well find proxies for those characteristics, such as like being named as Jared, like names as Jared, or playing high school lacrosse, and replicate that pattern. This sort of adverse impact can happen without explicit instructions, and worse, without even realizing. And these tools may not always be dystopian headlines, but they play a critical role in determining who has access to the hiring process. And another example is the top 5 resume AI model that was used by Amazon a while back. And it turns out that it biases against women. So what the model was actually doing, it was looking at hundreds of resumes. And from those hundreds of resumes, it was picking up top 5 resumes. And a lot of the hiring managers were starting to use this system to kind of like find the top five people and interview them. So what ended up happening is that the top 5 resumes ended up picking specific characteristics that were based on the historical data that was already present, because there were a lot of men in the jobs. They ended up using the historical indicators to kind of only pick the top resumes of men, and it ended up leaving a lot of women out. And now Amazon has never confirmed this, but they were using a third-party tool. They did end up stop using that tool eventually, but they have never confirmed this from their end. This is another company called Butters who have done the study and figured this out on their own. And these biases that are present in the recruiting systems, in the hiring system, they eventually does end up translating into the inequities that exist in the workplace. And we don't see many examples of it because that information does not get released openly. So another example that, next slide, please. So this you may or may not have heard before. Another study found that this was a study done by Georgia Institute of Technology, and they found that self-driving cars are more likely to crash in dark-skinned pedestrians. Now, this is just, like when I heard this for the first time, I was like, wow, how could this be happening? Like, this is such a basic thing, right? But this is exactly what they found. So what they actually did, they looked at a large data set of images contained pedestrians. They divided up the people using Fitzpatrick scale, a system classifying human skin tones from light to dark. And the researchers then analyzed how often the models correctly detected presence of people in the light skin tone versus how often they got it right for people in the dark skin tone group. Detection was 5 percentage point less accurate on average for the dark skin tone people. And the disparity persisted even when researchers controlled for variables such as time of the day, in images, or occasionally obstructing view of the pedestrians. So, and now another caveat here is that this is a third-party study. This study that I'm referring to, it has not been peer-reviewed, and it's not using the actual model that is used by the self-driving cars, because that model, that algorithm will never be released to the public. This is another third party that is conducting this study on their own, building up a similar model as self-driving cars to kind of figure out what exactly is happening. All right, so now you must be wondering, like, why would this be happening? I'm sure like already some of you have thought about ideas why this might be happening. Feel free to write them in the chat box. So some hypothesis is that the training on the ML model was done on the lighter skin toned people. So basically the data that they had was mainly including people of lighter skin tone. And let's say in cases where they did have dark skin tone people, the model didn't place enough weight on learning from those very few examples. So those could be some of the reasons that are possibly leading to this implications that we're seeing in the model itself. So let's go to the next slide, please. So now we talked about the hiring, we talked about the self-driving car. Now this one, if I were to rank all of them, I think this one is the most catastrophic example of all, because it has implications that are impacting somebody's life. And you probably have already heard about this because this is a very popular, controversial model that is already out there and people have talked about it before. So for those of you who don't know, it basically Compass is a tool that assigns scores from 1 to 10 that indicate how likely somebody is to reoffend based on 100 factors. And this is used for people when the judges are trying to, in the criminal system, when judges are trying to figure out what is the verdict, what is the length of the time the person would stay in jail. And they used 100 factors. The model uses 100 factors, including age, sex, criminal history, not the race. Race is not used. And these scores profoundly affect defendants' lives. And defendants who are defined as medium to high risk with scores 5 to 10 are more likely to be detained while waiting trial than our low risk defendants with scores 1 to 4. And ProPublica, which is another company, they collected data on Compass scores for more than 10,000 people that were arrested in Florida. And they checked to see how many of these how many of these people who were charged with further crimes within 2 years, how many people did actually reoffend based compared to these scores. So ProPublica found that among the defendants who ultimately did not reoffend, Blacks were more than twice as likely as whites to be classified as medium or high risk, 42% versus 22%. And this is a big number. And the number itself is huge, but the implications itself are even bigger, because if you are a dark skin tone, and this is the model that is being used to kind of score you, the chances are you will end up spending more time in jail than your white peer. Now, to be truly fair, the judge should have also used the score as well as when they see the scores and when they see the person who is in front of them, they should have also seen the skin color and their race when interpreting these results. Now, Compass did come back and say that their model is actually doing what it's supposed to do, and it's actually completely fair. And now going further back, maybe what's happening is actually the underlying data that is biased in itself that kind of is introducing the model to do whatever it is doing now. All right, let's go to the next slide. So now you all must be asking, can this be solved? Did I do anything? Let's go to the next slide, please. So I wish I had a magic bullet answer to this, but I don't. The only way we can solve this is using a human-centered approach. I believe us and people in this room are powerful because we have access to the data. We are the people making those models. We are the people taking decisions when these models are being built. And the only way to solve this is using a human-centered approach where we're educating the users and the creators. So we are, as a creator, are getting educated of issues like these, and unconscious biases that all of us tend to have are not translating into the work that we are doing. And creators and users who are actually using these models are actually aware of that these models can eventually be biased. For example, the Compass example that I gave, where I said the judge should also be looking at the score, but also as well as the person's race, and be mindful that there could be inherently bias in there. And again, like building diverse and inclusive teams in the product lifecycle is going to get us there. When we have diversity of ideas, when we are inclusive of everybody who the product and model is being built for, we can take all edge cases and all groups into consideration when we're building these models. And especially, like, I know, like, as a business, making money is the first thing, but as humans, we should be morally and ethically responsible when we are putting a technology out there. And those can all become through education and through ethics and being like more self-aware and being more aware of our own unconscious biases. And the last but not the least is the feedback loop, is create a feedback loop. Once you have built something, it's in the production, make sure that you are evaluating it again. Make sure that you have the fairness metrics that you're measuring, not just one, multiple of them, to evaluate how your model is performing against different groups, different use cases. So that way you kind of have like a more collective approach to not just building something, but also making sure that it's doing the thing that you built is doing what it's supposed to do. And with that, could you please go to the next slide? And with that, that would be end of my presentation. We all know that inequities do exist. Humans tend to be biased, and those biases do end up translating into the work that we do and the technology that we build. AI is biased because humans are biased. We collectively can solve this by being educated, being inclusive, building inclusive teams, and putting ethics and social responsibility at the forefront. And with that, thank you so much for your time. And I would open the floor for questions.
So thanks, Sundas, for the very interesting talk. Already there is a big discussion about it in Discord. We have some questions from the panel that I would like to ask you. The first one, it's about basically if the bias comes from people who do the analysis, if the bias is in the data set, also someone can say if the bias is related to the models or the interpretation that you're doing afterwards. Would you like to make a comment about the biases in a different step of the machine learning process?
I'm sorry, I lost you at the last part. What did you say?
Okay, so if you would like to comment, it's the question on the biases of on the different steps of the machine learning process, basically. The human bias, the dataset bias, the machine learning algorithm biases, the interpretation biases that we might have, these kind of things.
Yeah, so exactly as you said, there are many biases that can be introduced throughout the whole machine learning building cycle. And I know like my talk specifically focused on like the underlying bias in the data that exists itself and the human's bias that can kind of amplify it even further. But yeah, there are like different biases that could be introduced beyond that. And I know it's like somewhat easier to kind of figure out in a labeled data set where things are labeled and we can easily say like figure out like through analysis that maybe there's biases that is present in this data. And it's like I can imagine like this more challenging when we're working with like unlabeled data and like not supervised learning. And so I think it all comes down to like being more aware and making it part of the process when of like our machine learning model building process, where we are like kind of evaluating biases in each step, not just at the start, but also as well at the end. And eventually when it's launched as well, we're kind of like going back again and looking at it again and trying to see like if there are additional biases because maybe it's because human behavior is because introduced from human behavior or something else that is going on that is we did not expect to happen.
Okay, thanks. We have another question from Zainab. Does human-centered approach means that we need more post-processing or manual efforts?
I think we need more post and pre-processing. So pre-processing in terms of like just understanding the data set that we have, how are we feature engineering, what features are we including in our data set and the data set that we have, what does it look like? And I think this is somewhat we're already doing to some extent, but I think what we can do better is more post-processing. And it doesn't have to be manual efforts. I mean, it could start with like some prototypes, but eventually if we can automate, I think that would be an ideal solution, but obviously like adding more steps in the pre and post processing. And those could be done like through like developing fairness metrics, where you are evaluating the fairness of your model through some KPIs that you have developed along the way.